Sorry.
No, it's okay. Thank you. Thank you.
Always remind me. That's my soft spot.
Okay, great. So that's a great pleasure again to be here with you tonight and to share a topic which I'm quite passionate about, a topic related to creativity. And I've been involved with creativity for probably more than 20 years. I mean, at different levels, but lately, I mean, the progress also that AI has brought to the field of creativity, I found to be quite interesting, and I really wanted to share this with you. So I have a lot of content. I'm very frustrated just to have 1 hour to talk to you about all these exciting things going on in this field, but I will try to do my best to do it in 1 hour. So let me get started. I will try also to involve you along the process and to get you, if we have time at the end, also to do a little group activity, so you get chance also to interact a little bit more with your peers. So I will start with 2 questions, and these 2 questions are very simple. The first one is a quote from Pablo Picasso that says that computers are useless. They can only give you answers. So I would like you to think a little bit about this and tell me if you agree or not with Picasso. Can we expect more from machines than just simply answers? Can they deliver more than just simply answers as of today? And the second question is a very simple question also. Do you think that the artificial intelligence can be creative? So Moria, would you mind launching the first poll so all of you can answer to these 2 questions? First poll is, do you think that computers are useless and they can only give you answers? So you should have a poll that pop up in front of you now.
More.
Vote. How many respondents do we have?
83%.
Okay.
A bit more. 85.
Okay, great. So
yes.
Okay, so you close. You can share the results. Okay, so here are the results. So first question: most of you don't think that, don't agree with Picasso. You believe that. So 53% of you think that. Okay, hold on. Let me just mute. Okay. 53% think that yes, Picasso was not right or you don't agree with Picasso code. And in your opinion, can AI be creative? Yes, 77% of you do believe that AI can be creative. Only 11% of you don't believe that it's true. Okay, great, wonderful. So that's a good starting point. It looks like most of you are already convinced. So maybe I don't need to go further. No, I'm just kidding. But let's look at how really this AI can be creative and in which way it can be creative. So that's what I will try to do during today's session. Okay, so the first thing before we talk about creativity, we need to talk about intelligence. And I think that's something which is that we discussed a little bit before. How do you measure the intelligence of a machine? And the easiest way, is by using what we call the Turing test, or the traditional way is by using the Turing test. So the Turing test is just a simple test, well, simple by its concept, where you have someone behind a machine that will interact with a machine and with someone, and this someone might be a human being or might be another computer. And if the questioner is not able to differentiate if he's interacting with a machine or with a human being, we can say that the machine has passed the Turing test and can be considered as intelligent. So up to now, this has been the main criteria to define if a machine can be considered as intelligent or not. Now, board games have been, and strategy games have been a very interesting field for AI developers to, to compete and to challenge the world champion in different games. So I think Dr. Moria already mentioned a little bit about during the history of AI, the game between Kasparov and IBM Deep Blue, where Deep Blue was again able to win or to beat the world chess champion at the time. Later on, trying to move to different type of game where more text was involved or more reflection to some extent was involved, where where players or where IBM Watson, the AI machine, was supposed to create question based on an answer that it was given. Again, a challenge between the world champion and IBM Watson, and IBM Watson won the game. Now, there is one game, the game of Go, which is considered one of the oldest strategic board games that was invented in the world. So it was invented in China around 2005 years ago. It's estimated that around 46 million players that are playing currently the game of Go. 50% are based in Asia. So it plays on a board, 19 grid. And so you have stones, black and white stones. And so the main objective of this game is really to surround more territory than your opponent. And that's how you win this game. So this game is very strategic, and everyone thought that it requires lots of human intuition to be able to win this game, and that never any machine will be able to reach this level of intuition. So this was really the ultimate challenge for AI to be able to beat the world champion of this Go game. So if we look back, in a game of checker, for instance, so there are around 10 to the power of 20 possible combination possible. And that's a number which is quite easy for a machine to look at all the possible combinations. If we look at the game of chess, we move to 10 to the power of 40, which becomes a bit more challenging, but still, that's still feasible for a machine to look at all the possible combination before making the next move. Now, when we look at the game of Go, the number of possible outcomes or combination is 10 to the power of 80. Roughly, this will say that there are more combinations than the number of atoms in the universe. So it means that even the more powerful machine on this planet will not be able to evaluate all the possible combinations that are possible along the game. And so they had to find new ways to solve this challenge. So usually with a game of chess, they use what we call brute force approach, looking at all the combination, but with Go, as I could just said, it was not possible. So I ask all of you to watch, if possible, the game of, the movie AlphaGo. I will just be curious to see how many of you watch it, just to see a little bit how much I need to explain some of its aspects or not. Moria, will you mind starting the poll number 2? So could you just tell us, it's anonymous, so we don't know who did it or who didn't do it, just to get a quick glance of the. Okay, so most of you, well, around 1/3 of you got time to watch it. So I will highly encourage you to watch it because it really explains, it's a documentary, very well done documentary, which won a couple of awards also that explain a little bit how DeepMind, the company who created this, the games that competed, the AI systems that competed against the world champion, went through developing this AI system, went to test it, and really how the game played along the way. Okay, let me see. Can you remove the poll, please? Oh, let's see. Okay, I was able to do it. Okay, so just to give you, for those of you who didn't get chance to watch this documentary. So AlphaGo, again, is a system developed by DeepMind. DeepMind was later on bought by Google, so now it's a Google company. So AlphaGo, the name of the AI tool that was developed to compete against the world champion of the game of Go, was first trained by looking at previous games that were used by champions of Go to learn. So they fed the machine more or less with around 100,000 games, which are well-known games about, or strategy about playing the game of Go. And then they use what is called the reinforcement learning. So reinforcement learning means that AlphaGo started to play against itself. And how does it work? So reinforcement learning, I have an extract from the movie that I think explained very well how did it work, how does it work.
Vincent,
yes,
we can't hear it. You have to stop sharing and now share again. And when you share, there's a small checkbox for sharing audio.
Yeah. Okay, I done it. Sorry, I thought I did it the first time, but it looks like it was not reactivated. Okay, sorry about this, guys. Let me give it a second.
So here you control the bat and ball, and you're through this rainbow-colored wall.
Let me go back. Okay.
Games are very convenient in that a lot of them have scores, so it's very easy to measure incremental progress. So I'm going to show you a few videos of the agent system, the AI. So let's start off with Breakout. So here you control the bat and ball, and you're trying to break through this rainbow-colored wall. The agent system has to learn everything for itself, just from the raw pixels. It doesn't know what it's controlling. It doesn't even know what the object of the game is. Now, at the beginning, after 100 games, you can see the agent is not very good. It's missing the ball most of the time, but it's starting to get the hang of the idea that the bat should go towards the ball. Now, after 300 games, it's about as good as any human can play this, and pretty much gets the ball back every time. We thought, well, that's pretty cool, but we left the system playing for another 200 games. And it did this amazing thing. It found the optimal strategy was to dig a tunnel around the side and put the ball around the back of the wall. The researchers working on this, amazing AI developers, but they're not so good at Breakout, and they didn't know about that strategy.
Okay, so quite interesting approach, where the machine didn't know exactly any rules about how to play this game, learned the rule by itself, and found the optimum way to win this game. So that's what we call reinforcement learning. So the AlphaGo was trained to play against itself, so to see what works, what doesn't work, and learn like this. So the advantage of this approach is that AlphaGo can play millions or billions of games and learn from these games, where a human being, has some experience, but if they have played thousands of games, that's probably the most they could have done. But the machine got the chance to experience more than millions or billions of different situations, and every time checking what works and what doesn't work. So that's what we mean by this reinforcement learning. Now, when time came, so they invited the 18 times world champion of Go, Lee Sedol, to play against the machine. Lee Sedol was quite confident he will beat the machine. There are 5 games, 5 times before starting. And after the first game, so Lee Sedol lost the first game and started to realize that the machine was quite sophisticated and that he had a very challenging partner. So what happened is that during the second game, the machine played a move AlphaGo played a move which was very, very surprising to everyone. And so that's the famous move 37. And I just also have a brief presentations, that videos that talks about this particular move.
But even more important than AlphaGo's win was one moment during the game, the moment that caused Lee Sedol to leave the room.
AlphaGo played this move, which I want to hear more about in a second, but Lee has left the room.
He left the room after that.
He left the room after that move.
It was a move that seemed terrible to everyone who saw it, but it turned out that move 37 was an incredible move to play, and it was instrumental in helping AlphaGo win the game. Somehow, a computer program knew something about the game that we didn't. Somehow, its intuition was both different and better than human intuition. One of the players, Fan Hui, said, "It's not a human move. I've never seen a human play this move. So beautiful, beautiful, beautiful."
So really, everyone was really surprised and really thought that it was a bug of the machine and that the machine should have never played this move. And it reveals that this move helped AlphaGo to win the second game. So fortunately, I mean, it's a movie, and there are lots of emotion. I think you feel for this for Lee Sedol. I mean, you can see his little daughter, his wife crying, and everyone. I mean, his honor is at reputation. So he really wants to at least win one of these games. I mean, he's representing himself. I mean, his country is behind him. All the Go players are behind him, and can really a man still beat a machine at this game? And finally, game number 4 is able to again to make a move which is very, very, very unlikely to happen. And AlphaGo didn't expect this to happen and got a little bit confused, and it took advantage of this. So that's quite, like I said, that's quite an interesting documentary. And if you didn't have time to watch it, please, you will not regret it. Again, it helped also to change really how people play the Go game. And it really opened up some new avenues or some new strategy on how this game could be played and could be win. And so that's also the value that AlphaGo brought to the game of Go. Even so, a Go player now knows that, I mean, they might always be defeated by a machine. A machine might always be best than their best player. So how does the machine works? I mean, there is, of course, a lot of secrecy behind it. We don't know everything. But during the movie, they also share a little bit how the AI system is designed to evaluate the next move. So I captured also this little part, which I think is quite interesting for you guys.
Share a bit of what is going on in AlphaGo.
So AlphaGo has these 3 main components. There's the policy network, which was trained on high-level games to imitate those players. And then we have a second component, we call this the value net. And it can evaluate the board position and say, what is the probability of winning in this particular position? And then third component is the tree search, where it would look through different variations of the game and try to figure out what will happen in the future. So if we now take a position like this, first the policy network would scan the position and come up with what would be the interesting spots to play. And it builds up a tree of variations, and it then employs this value net that tells it how promising is the outcome of this particular variation. So AlphaGo tries to maximize its probability of winning, but it doesn't care at all about the margin by which it wins.
Okay, so when you see a slow-looking move, that's maybe an indication that AlphaGo thinks it has a good chance to win.
Yeah, that is a little giveaway.
So quite interesting to see that, I mean, there are different levels and different modules of the AlphaGo system. And I mean, through this combination of network and components, the machine is able to decide where to move. It's quite interesting also at the movie when you see the first move, first move, Lee Sedol play, and then we wait for AlphaGo to decide where he's going to make the first move, and it takes maybe a minute or a minute and a half for the machine to decide where this first move should be. So, I mean, everyone wonders, I mean, is the machine really knowing, or is there a bug or anything like this? But finally, things start like this. Anyway, these different parts were extracted from the movie, from the documentary. So if you want to know more, you can watch it. Now, what happened after, DeepMind created a new version of AlphaGo that they called AlphaGo Zero. And what they did for AlphaGo Zero, they removed completely the training that was made initially of these 100,000 games that were played by human beings. So they thought that this was more disturbing than anything else. And again, they let the machine train by itself. And so after 72 hours, the new AlphaGo version, so AlphaGo Zero, beats AlphaGo Lee, where AlphaGo Lee is the version that plays again Lee Sedol, 100 out of 0. So the new machine, beats the original machine that beat Lee Sedol 100 to 0. And after 40 days of training, so it reached a level where they believe no one could ever beat this machine again. So just to show you that they have continued improving the machine, even though there was not really a purpose for it. Now let's talk about creativity. What does it mean to be creative? So if we follow the definition of Margaret Boden, which is an author and a scientist, well written about creativity and artificial intelligence, her definition that I like says that it's something which is new, surprising, but also which has value. So if something which is new, surprising, and valuable come up, so we can say that it can be considered as creative. Now, let's go back to this Move 37. So can we consider this Move 37 as creative? Was it new? Yes, it was new because no one had seen any move like this before at this part of the game. Was it surprising? Yes, indeed, it was surprising. I mean, everyone thought that it was a big bug or that the machine went mad or went wrong. So it was surprising. And was it valuable? Yes, it was valuable because it helped the machine to win this second game. So we could say that this Move 37 shows some level of creativity. The machine was creative by, making this move a new move to the field of Go, of the game of Go. Now, let's talk a little bit about creativity, just simple definition, but that are important to understand. There are three forms of creativity. Let me go over each of them in detail. The first one is what we call combinational creativity. This is when you make unfamiliar combination of familiar ideas. So you recombine, you remix, you reorganize ideas or knowledge or technologies in a new way that was never combined before. And so a lot of innovations are based on this type of creativity. You can see, for instance, if you take the example of the iPhone, I mean, it was all the technologies that existed at the time to build the iPhone is just how Apple kind of put them together, package them together into the smartphone to be able to create something new. So if you're interested into this concept, so there is a documentary available online, which is called Everything is a Remix. I highly recommend you to watch this. And it shows that most of the invention, in fact, that happened were just built by reorganizing, remixing pre-existing ideas of the time or pre-existing technology in a novel way to create something new. Now, second type of creativity is what we call exploratory creativity. So in any field, if you take the fields of painting or any art or even any science, there are always some rules or constraints that are well accepted in this particular field. If you are able to, in this particular framework, to be able to take a new path or to explore something new in this context, then you're coming up with what we call some exploratory creativity. An analogy will be looking at this roadmap, and then you decide to take a new path, a new road not beaten. I mean, something new that no one has ever tried. and you discover that it leads to a new place or whatever. So it's under a framework, it's under pre-existing rules and constraints, and you explore something new. So usually the work of artists or researchers, I mean, work into this environment where they bring something new to the existing body of knowledge. The third type of creativity is what we call transformational creativity. So here, okay, we have this framework, but the creator here tried to change or challenge one of the rules or one of the constraints. So they change more or less this framework by adding some new rules or constraints. And an example will be in the field of painting, Picasso and George Braque, who came up with a style of cubism, which was completely new to the field of painting at the time. So they change, if you want, part of the rule and come up with something new. They are not operating inside the rule as exploratory. So how can AI tackle or handle all these different types of creativity? So the answer is yes. The most challenging type of creativity for AI, surprisingly, is what we call combinational creativity, so the first type. So yes, machine can easily combine, recombine, mix, and randomly try millions of different combinations. So that's not the problem. But the problem, remember, with the definition of creativity, something new, surprising, and of value. So yes, it will be new. Yes, it will be surprising, but most of the time it will be of no value. So the machine is not able to easily identify if what it produces is of value or not. And that's why combinational creativity is probably the most, one of the most challenging to produce valuable output. Exploratory creativity, when you define to a machine, to an AI system, what are the rules and the constraints, and you let the machine operate in this environment, then it can do very, very well, as well or even better than human being, and we will see some example today. And the last type is transformational creativity. So yes, AI system can do that. So you have systems that are able to adapt themselves. And when we talk about learning, like unsupervised learning or such kind of learning, the machine learn by itself, change its knowledge, adjust its knowledge, its rules, is constrained by itself. So that's what we could consider as transformational creativity. Yes, so AI can play with these three types of creativity. And maybe the first challenging one is a combinational, but I will show you today an example where this problem was overcome in a particular way. So how do you test? We know how to test the intelligence with a Turing test. How do we test if a machine is creative or not? So there is a paper published in 2001 that defined a new test, which is called the Lovelace test. So this is how it's written in scientific world. In easier understanding format, it could be stated that way. Can a machine originate a creative work of art such that the process is repeatable, not just a result of a hardware error, and yet the programmer is unable to explain how the algorithm produces its output? So meaning that's not something, it's not an, you have not developed, so the developer has not developed an algorithm and the machine just follows the algorithm to create an output, and the developer knows exactly how the machine came up with the output. It's more a black box where the machine has learned by itself and is able to produce something, but the developer has no idea on how it was done or how the machine came up with this. So if a machine is able to generate such kind of output, we can consider that the machine is creative. And again, it's called Lovelace test because it was given as a memory of the name of Lady Ada Lovelace, which was the first coder of history. She was working with Charles Babbage, and she was, she is the first developer to have written a program that was, launched on a machine at the time. And so Ada Lovelace, and that's why also you may know about the programming language Ada, it come also from her first name, just for the little story. Now, can machine, what kind of output creative machine do? So paintings, of course, machine, again, by learning from previous artwork, can develop their own artwork. So there are lots of projects that have been developed. This one is one of the most recent one, where an AI system was fed with all the painting from Rembrandt, and the machine was asked to create a new Rembrandt painting out of having analyzed all the patterns of Rembrandt painting. So here is a little poll for you, Maria, if you don't mind launching it. So in your opinion, which of these portraits was painted by AI? Is it A or is it B? Moria, if you don't mind launching the third poll. And I have a second question. Would you personally purchase a masterpiece created by an AI system? Okay, great. So which portrait was created by AI? So 63% of you say B, and bravo. So you're right. So B was created by the AI machine. And if you want to watch the movie, the nice documentary about also how it was created, you will have the link on the slide. I highly recommend you to watch it. And would you personally purchase a masterpiece created by AI? Interesting question. Yeah, 22% are not sure, 37% yes, and 41% say no.
Only 13 are not sure. We have a tie. Those with yes and no are almost the same, 22 and 24.
Oh, okay, yes, I was looking at the percentage. Yeah, 37% or 41%. So it's almost a tie, yes. Okay, so quite interesting. In fact, there has been portraits that was painted by a machine, and that was sold at Christie's auction a couple of years back, and was sold for $430,000 US dollars. So it looks like not everyone thinks that whatever might have been created by AI is not of value, because they have invested so much money into this artwork. But yes, it's a common feeling, and there has been a lots of interesting experiments that were done in museums where they just use paintings that were made by AI, not telling visitors that they were AI painting, and they told them at the end of the exhibit what they thought about it. And a lot of people felt cheated that, I mean, they really enjoy the paintings, but when they were told that they had been made by AI, they felt cheated and that it was not right. And so, I mean, it's still not commonly accepted, agreed that whatever is produced by a machine could be considered as art. And I will have a little discussion at the end about this too. So we can see also here through the audience that not everyone will invest or do it. And it's signed by more or less the formula which was behind the algorithm which composed this painting. It's at the bottom. That's signature of the artist. Another little quiz. Which one of these set of paintings were created by AI? Do you think A or B? So are all the paintings of A being created by AI, or all the paintings on the side from B have been painted by AI? Sorry, I try to keep you awake today. I engage you into all my little polls. Unfortunately, there is nothing to win, but at least we can get a sense a little bit of what you guys think. Okay. Can end the polling. 55% think that this is A, and 27% think that this is B. Okay, here I cheated a little bit. In fact, both were created by AI. So A and B were both created by AI systems. In fact, by the same system. And I'm going to explain to you how this system works, because it's quite an interesting AI concept. So it uses what we call a CAN network. CAN stands for Created Adversarial Network. So in fact, there are two AI systems working with each other. You have what we call the generator at the bottom left, which generate artworks. And you have the discriminator, which look at this artwork and say, well, this is art and this is not art. And if the discriminator judges that this is not art, it will, of course, provide feedback to the generator, and the generator will adjust what it produces to please the eye of the discriminator. So when I was telling you early on that combinational creativity is a challenge, here is an example where they were able to overcome this challenge. Now, let me tell you a little bit. I know you're quite curious about understanding how the generator generates and how the discriminator discriminates. And here is the answer to this question. So the generator and in fact the discriminator were both fed with some paintings that were taken from the WikiArt database with, again, a lot of paintings, a lot of different styles of painters that we, as human beings, consider as, piece of art or recognized as art through the human eyes. And so they classify automatically these different styles, again, by artists, by different elements. So the machine learns through by going and by understanding all these paintings. Now, how does the discriminator also discriminate if it's art or not? And this is by using what we call the Wand curve. So the Wand curve, in fact, has two axes. For something to be considered as art, it has somehow to have some level of novelty. So the horizontal axis measures the level of familiarity or novelty. If it's too novel, it's unlikely that people will consider it as art. If it's too familiar, again, people might question it. So you need to find a right balance. And then on the vertical axis, it needs to be pleasant to the human eyes. And again, so if it's unpleasant, it's very likely that it will also not be accepted. So the Wand curve has more or less a sweet spot, which is the one on the top, which has a certain level of novelty and a high level of, I don't know if we say that in English, of pleasiness, or it will please the human eye. So the discriminator, is able, based on what he has learned from previous artwork, to identify if whatever is presented to it fits this category. If it fits this sweet spot, then it will be considered as art and it will be kept, like the paintings I showed you early on. If it doesn't fit these criteria, then you have the feedback loop in blue that will inform the generator that, well, that's too novel or that's not pleasant enough to the eye, please readjust. And the two machine dialogue like this and are able to generate quite some interesting painting. Another interesting project I would like to share with you is this project by Google, which is called Deep Dream. In Deep Dream, a lot of efforts have been done recently for recognition, image recognition or pattern recognition in images, and computers have been very good at recognizing things. But Google and the Deep Dream team wanted to try to understand what really machine recognize when they see something. So here we can see a jellyfish. So they gave the original system that does image recognition use a neural network system. and they reversed it. So they used the output as an input, and they wanted to see what the machine will recognize and how it could be visualized. And so this is the output, more or less, of what the machine will see when it's presented with this picture. It will try to force and recognize shapes or patterns of things into this jellyfish, which is quite, a feature which is not, there's lots of things could be seen, but you can see the creativity of the machine also on all the things it can perceive. And if they push this to the next steps, these are other additional patterns that it recognizes in this shape. So this is how it's inside this black box, more or less, what the machine is able to do. So that's a project you can learn about also, and they have a website, Deep Dream Generator, where you can upload some pictures and some style. You would mix them together. You can do a lot of things with this. But I thought it was an interesting thing to try to understand a bit what is in this black box. It's not really explainable AI, but it goes towards this trying to understand a bit how does the machine recognize things and how it makes sense of it. There is a website also that you can also access freely that will help you also upload a picture, pick the style that you prefer, and it will transform your picture again following this painting style. What can AI do in terms of literature, of writing? Can he write poem? Just to save a little bit of time, I will skip this poll. You have a website which is called Bot Poet, and you're presented with a lot of short poems, and you are asked to see, was it created by a bot, by a robot, or was it created by a human being? And you will see that very often, you will make the wrong choice. So I could have asked you if this one was written by a robot or by a person. So just to save a bit of time, it was written by a bot. And usually 50% of the people think that it was written by a human being, but you can see a bit the level of sophistication, because again, a lot of people think that machine, will have problem to write poetry, and it looks like that's not the case any longer. Can it write a novel? So those of you who are fan of Harry Potter, who have read the first 7 volumes, 8th volume was created by AI. So the title is a bit funny, Harry Potter and the portrait of what looked like a large pile of ash. There is a lot of nonsense in this version. You can download it online also. But again, the AI machine was fed with all the previous volume of Harry Potter, and the machine created a new volume out of what he had learned from the first one. Now, Moria did mention a little bit about it at the last of her last presentation, I believe. Last year, there has been a new version of GPT-3. GPT-3 is called the Generative Pre-trained Transformer. Version 3 was released. So what is it? More or less, it's a huge neural network which was developed by a company which is called OpenAI. It was fed, again, this neural network learned from what is currently available on the internet, and more particularly on the web. So you can see that he used, some common crawling features to filter some content he was able to discover. He used some books database, he used Wikipedia. And this neural network is the largest neural network that exists currently in the world, with 175 billion parameters, so nodes, more if you want, in this neural network. So it learned more or less from everything that is posted on the web to try to understand what people are saying, what they are talking about, and how we are, as humans, sharing our knowledge and so on. And the things they have done, so it was created, like I said, in 2015. OpenAI was created in 2015 by Elon Musk and Sam Altman. Sam Altman is still the CEO. And what they were trying to do really is to create a huge neural network that anyone can tap into. And so there is a public API which is available. So anyone who develop an application who wants to use this huge neural network, which is text-based. So mainly It deals with text. It can answer questions. It can do a lot of things. I'm going to show you a little bit what it can do, but it's all text-based. But it's amazing what it can do. So I'm going to show you, instead of trying to explain it with my own words, I'm going to show you, I capture a set of different videos and combine them to show you a little bit what this machine can do. At the end of this video, you will see also an avatar which tap directly into GPT-3. So questions were asked to this avatar, and this avatar answered to this question based on using GPT-3 as a source of answer. So I will let you watch this. Quite interesting, the different applications that exist as of today, and there are hundreds of them, and what they can do by using GPT-3 as a backend system.
Has built a plugin to Figma that allows users to enter a description of what they want for an application. So in this example, a user is describing an application with a feed and some icons and a user interface. And when he hits submit, the application actually generates an application that looks very much like Instagram. It has all of the buttons, all of the UI, and a scrolling feed. Just astounding in terms of what it's able to do. The next example is a coding example. And so this is dbuild.co, and they're describing an application that is a basic to-do list application. And so what the software is doing is it's generating a React application, all of the functions and procedures, all of the things that are necessary to create a React component to handle to-do. And you can see it works. You can add items to the to-do list. There's all the events and triggers for handling the interactions of the application, and it's all generated on the fly by artificial intelligence. Just amazing what we're able to do with AI, both the design and development aspects. The next example is in Excel. And so we have a table with headers of company, ticker, and year founded. And we ask OpenAI to complete the table, and it's able to fill in the entire table with the data that it thinks we want. Again, it's pulling this information from its corpus of artificial intelligence, and it's trying to be predictive in terms of what it thinks we want in the table. If we don't agree, or we want to train it a little bit differently, we can queue it with different elements that start in the table. So here I actually want the table to be filled in starting from the newest to the oldest. And so I put Twitter and Facebook and then ask it to predict the table. And it's able to understand what I'm trying to do. And again, goes top to bottom all the way in, filling in the year founded information with all the company information. So this example is within Wikipedia. So if you've ever seen a long article, you can't really understand or find the information that you need, you can simply have a plugin where you ask the exact question that you want. So in this example, I'm asking, why is bread fluffy? And it's searching the data and information in that article and generating an answer to my question and giving me a citation and location that I can jump to. So really summarizing the data, making it really easy for me to find exactly what I want from large volumes of text and information that are presented. Because of the vast amounts of information within GPT-3, you can really ask it anything. In fact, you can almost use it like a search engine where you ask it a question, it can give you one result, giving you the citation of exactly where to find that answer. So Google and Apple and Amazon have thousands of engineers working on this problem, and we're able to use this artificial intelligence to solve a very similar problem almost instantly. Just amazing what you can do with the tech. One of the common applications of GPT-3 is translation. So here we can give it an example of an English sentence that we want translated. Your order will arrive in 7 to 10 business days, and ask it to translate into French. We can also use translation to translate things that are written in legalese. This is an NDA, non-disclosure agreement, and translate that into something that a second grader would understand. Real applications for the technology. You can use the artificial intelligence to generate quizzes based on information that you have. So it can generate vocabulary or questions and then show you the context of where it's getting the information for the quiz that it's generating. It can also be used for entertainment, such as role-playing and generating a story with multiple endings or multiple directions in which you can go. A really early exploration of what the technology is capable of, but gets your imagination going in terms of what's possible.
Okay, and sorry, I looks like the AI part was not part of it. I will send you the link to the part where we see the avatar. Quite surprising and even a bit scary to some extent. I will send it to you through the by email.
Has built.
Now, OpenAI, with the company who again created GPT-3, has also lots of very interesting projects. So OpenAI is more or less a competitor of DeepMind. I mean, they are all working on this very advanced AI project. I just pick a couple of, you can go to the OpenAI project page, but I selected few of them that I found to be quite interesting and maybe novel. One is called DALL-E for, I guess, Salvador Dali, the painter. And what it does is that, again, by using also GPT-3 on the back end, but by using also some AI systems that can produce image, you will type whatever you want the machine to display. So here it was typed an illustration of a baby daikon radish in a tutu walking a dog. And the machine will automatically generate some pictures, not find some picture, but will generate some pictures that match this criteria. Second prompt, for instance, you will type to the machine, I would like an armchair in the shape of an avocado. And the machine will generate lots of pictures of chairs in the shape of the avocado. So you can see already, I mean, the power of such machine in terms of creativity. I mean, you can explore, and it will not just give you 5 examples, it will give you hundreds of examples of chairs that looks like an avocado that it has created itself, not that he has found image on the internet about. So you can see the power of creativity also attached to it. Here, an interesting also project from OpenAI, where they give the machine half of a picture and they let the machine complete the other half of the picture. So you can see 4 pictures on the left, and the machine let the machine complete the picture by itself. Again, not by trying to find the picture on the internet, by trying to imagine or predict or create what it could look like. And you can see what different versions the machine was able to come up with. And on the last column, you have the original picture, what they look like. So quite, again, shows the potential of the machine to explore or to further develop your own human creativity. When it comes to music, I think music was the first field where AI was applied in the arts arena. I mean, I think there has been over the past 30 years or 40 years, there has been some experiment in how to use or how to analyze the work of composers, musicians, like, I mean, very popular people like Bach, Mozart or whatever, and recreate a new symphony from them. Again, by having analyzed all their composing style. So here is an example, for instance, based on Bach. So yes, it does sound like Bach, and experts also, I mean, have problem to differentiate if it's something that was created really by the composer or something that was created by the machine, but it was purely created by the machine. So again, this is not something new, I will say. Now, you start to see some website or some companies like Amper, where if you need a particular jingle or a sound or music for the background or for your website or for your videos or whatever, you can get an account. You can specify what kind of style you want. I mean, you have a lot of different parameters that you can select from, and the machine will create just for you a particular music. You mentioned also you want it to be 10 seconds, 1 minute, 10 minutes. And the machine, the AI system will create it for you, and you will own also the copyright of what was created by this machine. So quite interesting and quite useful and very cheap compared to, I mean, asking someone to compose a short music for you. But I was also very much surprised by, again, work done by OpenAI, what we have seen in the past was mainly some music that were composed based on analyzing previous style. Here, OpenAI pushed it to the next step. Not only there is music, but there is also singing that was attached to it or that was developed by the machine. So I just picked one example. So they have created a lot of different songs. I just picked one which is called Blues Rock. And again, the music and the lyrics and the singing were all produced by the machine. So quite surprising. And again, the lyrics, of course, were also created by the machine. So the singing, the music, everything is created by the machine, and the machine can create like this huge number of songs. Yeah, some of them have more or less meanings than others, but just to show you what can be done. Recently also, IBM Watson created a trailer for a movie. Movie is called Morgan. And so what the machine did was they had people watch the movie in a room. People had some sensors, and when the machine detected that the people had some strong emotions by watching the movie, they captured these sequences where emotion were high, and they recombined them automatically and created a trailer. So the trailer of Morgan, you can watch it, was created by the AI itself by capturing and rearranging and remixing some of these important moments of the movie. Quite interesting. Now, the final frontier of creativity usually is humor. And I mean, to get to be funny, I mean, it requires, and again, to be funny in the humoristic in different contexts, I mean, or in different culture may vary. But there are also some AI projects that have worked into this sense. And I'm going to show you a joke. I mean, there was a website where you can see also lots of jokes that were created by machines. But I just picked one among others, and I will let you read it on yourself, by yourself. So that's not the kind of joke where you will pee in your pants, I will say, but I think it will still bring a smile on your face, and I think that's already well done. So if you go to the website Joking Computer, you can see also hundreds of jokes that were created by machines. Yeah, I mean, I think there is still a lot of way to go, but I mean, again, humor is really something which is very, very complex and has some rules, but has also a lot of other things that have not been articulated. I like this quote from Einstein, and says, we cannot solve our problem with the same thinking we used when we created them. And I think it very well highlights the value of all these AI systems that we have seen. So DeepMind, for instance, has a project called MuZero, learning a model of the world where the rules of the game are unknown. And that's what we are currently facing in a lot of different aspects. We don't know what are the rules of the world. If we look at the Go game, remember I said the new version of AlphaGo didn't take in consideration anything that was used by the humans, because it was not making the system as good as if they were ignoring everything that was done by human being before. So that's quite an interesting thing, is that machine now can analyze so many parameters or can try so many things on their own that they are able to discover new knowledge that as human we will not have expected. And we have so many biases and also on what we think is right, is wrong, is good, is not good, will work, will not work. Machines don't have this. And by letting them explore by themselves, they can generate some very valuable knowledge that we can reuse. So in science, there are many, many examples that have been applied. So I will not describe them in detail, but you will have also the source to watch them. Again, new antibiotics that were created by using AI. A lot of new discovery were made about the COVID and how the COVID also impacts the human body were discovered by using also AI system and some of the supercomputers. And DeepMind has also an interesting, so DeepMind, which came up with AlphaGo, as a new system they called AlphaFold, which is able to looks at protein structure prediction. That's something which is very, very complex and that scientists, biologists have been working for years and were not able to decode. And through AlphaFold, there is also a nice, interesting documentary that you can watch online about this. AlphaFold was able to make so many new discoveries that are going to help to develop new medication and new treatment in a lot of disease. So we can see that these AI systems are not just used to play or to beat the world champion in whatever game. Now they are leading to new discoveries that bring up science to the next level. I wanted to ask you if you still believe that AI is creative or not, but we are running a bit out of time, so I will not do that. Let me, if you allow me to have 5 more minutes.
We have 15 minutes or 14 minutes because we're working now on 75 minutes.
Okay, wonderful. So let me take advantage of this. So can AI imitate human creativity? I think all of us now, have the answer is yes. Will AI replace all jobs? Well, a lot of studies show that it will not replace all jobs. It will help to automate some tasks of each type of jobs. Jobs that are more manual, maybe more automation will happen. Tasks that are more knowledge-oriented, maybe less automation will happen, but automation will happen in any type of job for sure. So employers, companies are looking more and more for creativity, originality into the people that they hire, into their employees. Now, studies show that there is a decline in creativity levels in children, which is a bit scary. And as we could see, there is also an increase for creative problem-solving skills. So this goes in the opposite side. So we are always told we need to work faster, smarter, and harder. And I believe if we do that, and I like this quote from Benoit Raphael that says, if humans are afraid to be replaced by robots, it might be because they work like robots. So maybe we need to stop thinking also about what we do and how we do it and not follow these rules any longer, but look at where we can bring value as a human being. And knowing that computers anyway are very fast, they are extremely fast, they are much faster than we are, they are much more accurate, they don't make so mistake as we do, and they are super connected compared to the human being where we are quite lazy, our brain is lame, we make a lot of errors, and we are almost not connected. Our brain is connected to ourselves. Yes, we connect with other human beings, but we don't exchange knowledge so easily, or we don't acquire knowledge so easily. So we should not look at human versus machine because we're going to lose this competition. More or less, we need to look at the collaboration, how human and machine can collaborate. And here, particularly in the field of creativity. So again, if we look at the field of arts, what's going to happen and what's starting to happen? And that's why I asked you the question early on, will you buy artwork, a masterpiece based from an AI machine? And you said, most of you, said probably not. And that's exactly the same thing that happened when the first camera came out. People say, well, photography is not an art. You just use a tool and the tool takes a picture for you. What's your value? What's your contribution? And it took time for photography to become considered as an art because that's not really the device by itself that makes the photography or that makes it turn it into a piece of art is really, the photographer and how they take the picture, for which angle, for the amount of light, for the composition and everything like this. I like this little story also that illustrates the same concept. After a classical music event, a lady came to see the violinist and told the violinist, "Maestro, your violin makes such beautiful music." And the violinist took his violin and showed it to her and said, "Listen, I don't hear anything." And so you can just make a joke and say, well, for sure, this violinist will not be able to play such beautiful music without the device itself. But at the end of the day, just the device cannot do anything by itself either. So that's the collaboration so the violin or the camera are a tool that the artist can use to express his talent or to express his or her creativity. And that's how it needs to be perceived. And currently AI is not perceived yet as is, again, because as you said, well, if it's produced by AI, maybe I don't feel it's art, or I don't feel it has the same value as it was created by a human being. So interesting question here. So there need to be this continuous interaction and feedback between the AI subsystem and the human being. So human needs to be in the loop for sure to help guide, direct, and but at the end of the day, the AI system will not be able to produce anything on its own. It's just a tool. Just some experiments. Also, Google has been doing a lot of interesting things. Again, you can explore what they have been doing online. I just selected a couple of examples. Here is an experiment where you will start to draw something. Let's say I draw this pink curve on the left, and I say, what will a ship look like if by using this curve? And the system will draw all kinds of ships, again, by reusing these initial lines that you have drawn. And so again, it shows you how, based on the starting point, how the machine can further explore or develop one's creativity. Another tool that was developed, released not so long ago, which is called Google Chimera Painter. You paint something in 2D, in 2 dimensions, and Google will turn it into a 3D animated character. So you don't need to learn about how to create 3D animated character. You paint it in 2D, and Google will do it in 3D. Here's another example with a rat, maybe Ratatouille. And again, how it's automatically converted into a 3D things, just by, again, by the help and support of an AI tool. Now, recently also, we start to see some humanoid AI artists. Here is an example of a humanoid who painted her own portrait. It's a little bit like Vincent van Gogh, who painted his own portrait. Here, by looking at a mirror, she painted her own portrait, and that's what the portrait looked like. And she's a humanoid. She's not she looks like a human, but she's a humanoid. You can see her arms, and her brain is driven by AI. But we can see also a humanoid start painting and also expressing to some extent their creativity. So can we consider Ida? And again, her name is Ida. Again, going back to Ada Lovelace. Ada Lovelace got a lot of, I think she inspired a lot of people, and Ida comes, again, her first name comes from Ada Lovelace's name. No? So can we consider this humanoid or this AI system as artist? And going back to the, again, to this CAN network, I mean, currently, as of today, I think, I mean, to me, and again, not everyone might agree with that. I mean, they lack this social context that helps this machine to be able to, I mean, create something which tell a story or make sense or convey a message. And I think they are not able to do that at this stage. And this is because I don't think at this stage that machine knows if they are making a new painting or composing a new music or doing or playing a video game. In my opinion, they are not yet aware about what they are. And I think that's a little bit what we started to discuss last week. Do machines reach some level of consciousness? And will they even one day reach some certain degree of consciousness? That's again very debatable. And I think someone said something I liked very much last time, that why should we try to emulate human consciousness? And I agree with that. I mean, this machine might have their own consciousness that is different from human consciousness that we might not be able to understand yet, but maybe one day we will be able to understand further. So my last slide, I wanted us to do an activity, but I think we might do it offline. And I will explain how we can do that later on. But I believe the future of creativity really lies into what I could call augmented human creativity or hybrid creativity or super creativity. I mean, we can name it differently, but I believe that's where the collaboration between human and machine now are going to be able to explore so many new avenues that human could not explore on their own because it didn't have the time or the resources to do so. But machine will be a great help to artists to really explore new things. And I think this should, not only artists, but I will say everyone in the working for creative industries are affected. As you could see, I mean, in my example, you can just give some initial thought to a machine, initial direction, and let the machine explore. So if you want to design a new bag, if you want to design a new clothes, if you want to design anything, the machine should be able to assist you. And I think if people, designers in all this creative industry are not yet taking advantage of them, they should rapidly do so because they will very rapidly fall behind if they don't do that. So what is a link to KM? That's the thing we will do offline. So I will just pass rapidly into it. And so just want to thank you. I will, we can have a discussion. I think we still have a few minutes and I think it would be interesting. There are two quite interesting books that talks about this, and some of my presentation is inspired from their work too, which is called The Creativity Code by Marcus du Sautoy, a British mathematician, and The Artist in the Machine by Arthur Miller, which is an American scientist working at MIT, I believe. And we have written very interesting books, again, that talks about AI and creativity. So that's it for today. Sorry for being a little bit over time, but as you can see, I'm so excited that I wanted to share so much with you. And hopefully I was able to convince you to some extent that machines are getting more and more creative, at least. Thank you.
Thank you, Vincent, dear Vincent. Next week, Annie will go down to earth from all the ideas she spoke about, and she will give us a handful of projects, examples of AI initiatives, AI projects in organizations. So we are all curious. We have a task before pre-assignment reading. I hope it will help now, and I'm sure that people will go back also to Vincent's pre-assignment reading, not reading, video moving. Yeah, videoing, watching. So thank you all and see you next week. Bye.
Bye.
Bye-bye. Thank you. Thank you, Vincent.
Thank you all.
Very good
Bye.
session.
Thank you.
Thank you so much. Be in touch.
Bye.
Please stay in
Thank
touch.
you.
I really
Thank
liked it. All the
Very
examples.
Thank you.
Bye.
Moria, can you save the chat session? I don't know if I can do it.
Saved.
Okay, thank you so much.
You're sending me now the link because I want to add it. There was a link, a missing link there to the movie, to the film where you wanted to show a specific quote on AI. Even though
Yes.
I loved the creativity of defining a new telephone application or new computer application, I think that it's creativity 100%. But
Yes.
whatever you want to send me, please send me now, and I'll add it to our to the email that will be sent shortly.
Okay, I will send you the, yeah, so there is the avatar, which the part of the avatar where